Aloha, Richard Halverson here. This is ITS128, and it is like November 2nd. And let me share my screen. So 128, we are in, we're in this week. It's 2 weeks, but we need to cover chapter 7. It's a very important chapter, and we can get back to these other ones if you have questions during class. You can ask me later, or you can come on Saturday, and that's what I do those. Do a lot of labs for anybody, for anybody that asks. So let's go to chapter 7. I've started it up here, and this is strings. Okay, and strings are they're like lists of characters. We've gotten, no, we haven't really covered lists yet. Okay, so a string is a string. It's a bunch of characters, and you can refer to the characters individually of the string by doing this indexing thing. Okay, and the indexing thing is as fancy as you can imagine. So if you have a string, like here you have a string, and this is the definition of the string. You can refer to individual characters. The numbering starts at 0 and all the way up to whatever this the length minus 1 is that one, and this thing will refer to, as you might think, from character index number 7, from index 7 up to, but not including the character at index 23. So in this particular example, we are trying to slice out this, slice out this, and this must be character index 7, so it must be the 8th character, and this must be character index 24, I guess, character index, because it goes up to but not including the upper digit. So it's index 0, 1, 0, 1, and 2. Yes, 0, 1, and 2. And one thing that you will notice right away is if you want to figure out how many characters this is, it's just this minus this. You don't have to worry about thinking if do I add 1 or subtract 1 because you're including both the front and the back, and you want to find out the length of it. And so that I think is like the main reason why they always have you, and other languages aren't this way, but when you give the range, some other languages aren't. You give the number, the upper limit, plus 1. All right, so that's an important part, and this stuff is these indexing things are very versatile. There can be up to three of these numbers here, and they can be negative, and there's just a bunch of things, and we sort of learn what all this is. Let's see here, for example, can be used to specify the index relative to the end of the string. So this is 0 all the way up to the end of the string minus 2. So here we have a string Jane Doe, and the end of the string minus 2 is this exclamation point. Yes, yeah, the index of is this, right? Yeah. Wait a minute, that's not right. Oh, I see. This, yeah, right. So this is the so it goes 0 to this character -1, and so this character, yeah, so this character -1 is the exclamation point. Anyway, if you look at this, it'll you look at this a few times and you get used to it, and then you don't make mistakes anymore. In fact, this it's harder. It's almost harder to make mistakes once you get the hang of this. All right, so so this exemplifies that. Here's okay. Determine the output of the following quote. So it's 0 to 3, so there would be 0. This is 0. This is 1, and this is 1, and this is 2, and so that's what it should be, I guess. And yes, position 0, 1, and 2, because it does not include 3. So this would be 0, 1, 2, 3. 3 is a space, I guess, and then 4, 5, 6. Yes. Yeah. All right. So slicing and slicing operations. Let's see. I'm not quite sure the point of this, but thus creating a slice of the string variable, then changing the string does not change the value of the slice. Oh yes. All they're saying is that if you have a string here like this, and then you take a slice out of it, and then you go and change the string, it's not going to change the slice, obviously. I guess that's not obvious. And let's see, omitting the start index such as that yields the characters from indices 0 up to -1. So a programmer often wants to read all the characters that occur before or after some index, so you can, you can omit the indexes if it's all the way to the end. See, so that's a convenience. And so this goes from character 5 all the way up to the end. So here's a participation activity. You can change these things, and you can see what portion of the string is sliced out based on these indexes. Okay, run the program. We read in a string. See, you can put functions in here that evaluate to an integer. So this takes the length of the string divided by 2, and then this takes it from that number all the way to the end. So it's going to be the first half of the string. This is from the beginning to half of the length is going to be the first half, and from half of the length to the end is going to be the second half. And because the upper specified integer is not included, but the lower specified integer is included, then you can just do it this way. You don't have to worry about whether you're getting the middle one twice and all that. All right, and so this just prints it out. So that's what this does. So you can see that so how about if we do 1, 2, 3, 4, 5, 6, 7, 8. We get 1, 2, 3, 4, 5, 6, 7, 8. What happens if we do 9? What? Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because if you do the math, it's 9. 9 divided by 2 is 4.5, but we're just taking the integer of it, so it's 4. So this is why we have 4. This is character 0 through 3, and then we go from 4. It's the same expression. 4 up to the end. All right, so this gives some common examples. You can see that 10 to 19. This goes from 10 to the end of the string, 5 in, and so on. Okay, so this tests your understanding of not putting an index there. Okay, there's this thing called a stride, and that's like, you know, like let's not take them all, and let's skip every one or something. Let's skip every other one. And so there's this stride. I guess there's times when you may want to use that. So 1 is the default. The stride defaults to 1 if it's not specified. So if you only are using 2 integers, which most of the time you are, your stride defaults to 1. But if you want to have a stride, then that's what this third number is here. So this just goes from 0 to 4 with the stride of 1. So it's just going to be AGT. It's going to be 5 characters. So AGT to T. 5 characters. And this is going to be from the beginning to the end every 2. So does it include the first one? I think it includes the first one. Yes. Yes, it includes the first one. Okay, so that means it's A T T A C K, clever, huh? Attack MARS, attack Mars. Clever. All right, this challenge activity, you can do these. So it's so easy. Slice a rhyme by assign this by slicing. Okay. Huh? What's the rhyme? Oh, here, okay. You start an index. Oh, you're slicing. Okay, got it. Okay. So we want to put in the 2 index digits for this. So I would say it would be. Don't we just put start index colon end index? Um, 0, 1, 2, 3, 4, 5, 6. All right, well that's easy. This is kind of a dumb thing here. Okay. All right, let's go to advanced string formatting. This is a short chapter, isn't it? Okay, field width. Now, where is this used? Oh, I see. So when you're printing stuff out, you can specify the width. So, you know, you can make columns, basically. You can make columns. But they have to be, you know, equally spaced characters. All right, in the above example, the text formatted into columns. All right, well, so we are going to be printing out 2 names and goals, and so we're going to define the format string beforehand. We can do that, and so here we're using that format string, and we're going to put this is going to go here, and this is going to go here. And so you can see that the first one prints the player's name, and it takes up 16 spaces. And the next one after that takes up prints goals, and it takes up 8 spaces. But anyway, you see it down here. You see player name, and then and that should 16 spaces goes all the way up to here, I guess. Anyway, the problem with this is that they're both left justified, so we have to right justified goals. Do they tell us that next? Excuse me. Aligning text. Okay, here we go. So, okay, here we go. This is left justify, which is the default, and this is right. This is right justify. See, it's right justified. So really, what you would want is you'd want player name to be left justified, and this is centered. So yeah, that's, yeah, you probably want you know, this one and this one, because you want this to be left justified and this one to be right justified. Maybe, I don't know. But anyway, see, isn't that neat? All right. Yeah. Otherwise, you'd have to write code. You have to write a loop to put the spaces in there and test the length of the thing you're printing out, and then fill with spaces. And so anyway, let's see. For each question, determine the value of the given expression. Okay, so it's going to be left justified Bob, B-O-B, and do I put space or no? It didn't matter, I guess. Oh, you do have to have the spaces. Well, what do you know? Okay. Of course you have to have the spaces, because if there was another one, they would have to start at the right place. So this one is going to be space B-O-B. All right, so you can do the rest of these. Oh, look, we can specify what is filled. And of course, the default is blank, so you don't have to. So you don't put that. Right. You don't put that here. Here, for example. Right. It would be for a grade. Okay. I see. Look at that. Okay. So you can specify what the fill character is. Well, that's pretty interesting. Okay, so here we're just default empty space fill character. So we're going to have the name is going to be left justified. The goals are going to be right justified. You can take up as many as 6 spaces. And here the name is up to 16 characters, and the goal is going to be 0 filled. 0, 0, 0, 0, whatever. And then here, I guess there's going to be underscores. There's going to be underscores all the rest of the way. Okay, let's see it happening. See, so it prints that way. Next one prints that way, and this one prints that way with underscores up to it. So that's pretty neat. This is going to do asterisks. What is the field character in the following format specification? Duh. I don't know. You can answer that one. it's going to be right justified Sally. I think it's going to be this one. Floating point precision. Okay, we've done these before. I've seen. Okay, so this is just. So here, if you the colon is gonna means I guess it doesn't matter how many digits to the left of the decimal point, but it's going to be one digit to the right of the decimal point, right? So if you're printing this and you're using this format only specifies one digit to the right of the decimal point. So it's going to print like this. This is going to be like 3.14159, you know, long repeating number like that. And then this is an approximation of pi, which is 22 divided by 7. That's an approximation of pi, and that's like this. You know, it's 3.14, and 3.14, and then 159 does round to 2, but anyway. And then so that looks better like that, right? So here we're just printing out pi, and we're just printing it out, I guess. Yes, because it's this. Okay. So that's pi is this, and then this prints out the whole thing, but then this does the formatting. So this is the formatting. Printing pi, see, we're specifying the name. We're not using positions. We're naming them. So and this does 2 digits to the right of the decimal point, which is why we have that. All right. So you know, probably what you're going to do is it's not until you write a program, or it's not until you write some programs where you want to specify these formats, are they really going to stick? But you can always look them up. And that's why, for example, in the next, in 148, we use the same textbook. It's just that we do, you know, there's more chapters. We go like up to chapter 20 or something. But all of these earlier chapters are left open. I leave all these earlier chapters open because you're going to want to go back and reference someplace. Let's see, that was in 7.2 where we had all those examples of all the different ways of formatting. So let's see, what are we supposed to do? Well, 1 decimal point followed by C. Oh, let's look like that. So I guess it's print. I'm not too handy with these prints. Print, let's see, I need to do a this thing. This. 0.1, oops, 1, end dot point format, air temperature. Now, is that right? Let's see. Oh, I need an F. And what else? Oh, I could do it this way, but I'm not. Am I supposed to do it that way? Well, I'm not. I could put, you know, air temperature there and put air temperature equals air temperature or something. But anyway, so let's see what this works. Oh, I forgot to end the parentheses. Oh, I forgot to put the C in there. What do I do? Like, do this? Is that where I put the C? Oh, yeah, it is. Okay, great, cool. All right, string methods. There's a whole bunch of string methods that you're gonna get used to. And that is something that you're gonna want to look up sometime. So there's a bunch of lists of them. Here's a bunch of string methods, and we're gonna learn what they all are. Ooh, look, all these. So, okay, finding and replacing is a very, very common one where you have a string, and the way you get at these is you have a string, it's a string, and then you say dot, and then the method, the function. And so this is going to replace every instance of one with uno. So everywhere there's a one, they'll change it to an uno, except for there are no ones because it's got to be capital. Okay, let's see what this does. So something's going on down here, darn it. Right, it doesn't change that one. Oh, here we are. Oh, it's going to change the 3, the 6, and the 9. So there it changes this, and then now it's going to change the 9. Boom, there, away. Okay. This method is going to return an integer, the index of whatever it is you're looking for. So it returns the index of the first occurrence of item X. Otherwise, it returns -1, which makes sense because if it returns 0, it would be saying it begins at the first index or index 0. So the index of the first character is 0, not 1. Yes. So if my str is equal to this, boo-hoo, with an exclamation point at the end of it, the index of that is going to be 7. Let's see. 0, 1, 2, 3, 4, 5, 6, 7. Yes, it's the 8th character, index 7. This returns 0 because boo is starts at index 0, and this is 1. First occurrence only. And this, if you add this, then that's where you start the search. So if you do a 2, the first occurrence is at 1. Yeah. So if you do 2, it's going to have to go all the way up to this because 0, 1, 2. If it starts here, then of course it doesn't. There's not another O after it. So, and then so here it starts. It's here you specify when to stop the search. So you're looking for this string within these indexes. All right, same as find index. And this is right. Starts from the right. Very valuable. If you don't have this, you'll notice that languages have a reverse string, where you want to find but being able to find the last index is a pretty valuable thing, and you'll probably use that a lot. Of course, count just returns the number of characters. Okay, and this, if this is in this, okay, so that means this just needs to be anywhere in here. So in other languages, you would look for the position. You'd have to look for the position of Batman in a string, and if it was and if it returned true, then it's there. If it returns false, it's not there. PHP has that function. All right. So here, let's see. What does this do? Oh, hang. So here, there's a hidden something. This is a word, and you're supposed to guess characters, and each time it it finds the position of that character in the string and replaces that underscore with that. And all right, I don't know, you can let's see, what is this? Let's run it. All right, anyway, so like I said, if you've played that before, that might be interesting. Okay, so there's string comparisons too. A string can be greater than another string, and what you do is it's alphabetical order. Okay, starting with the leftmost character. So this is greater than this just because y is greater than a already. Okay, you know, this is equal to that, and so that works. The double equal sign works. This of course is not true because this has got an exclamation point at the end of it. It's true that this is greater than this. It's false that this is, because Yankee all the way up to S. S is not greater than, Z is greater than S. Characters of both sides match until the second word, the first character of the second word is S, and it's not greater than Z. ASCII value. What's ASCII value? ASCII table. ASCII table. Here's an ASCII table, and it says what the ASCII values are in decimal, hexadecimal, octal, HTML, what that character is, so on. So we have capital S is 83, and capital Z is 90. So 90 is greater than 83. In this test the in function, this is in this, it's right there. This is not in this because this is not the same as this. So this tests your understanding of the string comparison operators. And this is so we read in a student name. This is after student name, identity operator. So identity student name is let's see if this has to do with whether the objects are of equal value or they're actually the same. So this is testing if it's actually the same object. This just tests whether the two objects are equal value, if it's two objects. And student name was read in as Amy Adams, but that's a different object than this particular object right here. They happen to be equal. They happen to have equal values contained in them, but they aren't the same one. So anyway, that's the point here. That's between is and the equal sign. You know, you probably always want to use the equal sign. And then these these methods just test stuff and returns true or false. So this is this tests to see if all the characters are alphanumeric. Alnum is alphanumeric, and alphanumeric means it can be lowercase characters, lowercase letters, uppercase letters, or digits 0 through 9. This tests to see if all of the characters are digits. This tests to see if everything's lowercase, everything's uppercase. Tests if all the characters are white space. So it can be a blank space, it can be a tab, it can be a return. If it's just all those characters, then that's what this tests. It'll return true. This tests if it starts with something or it ends with something, and it's a string. Is lower and is upper, ignore non-cased sentences, or it's non-cased characters. So if you're asking if this is lowercase, it is lowercase because the letters are lowercase. But this is how, you have a string of an object. It's a string. It contains a string value. Therefore, it has this method that goes along with it. So this tests your understanding of, is this all alphanumeric? No, it's not, because it's got it's got this stuff in here. It's got that in there, and it's got this in there. So I would say it's false. And the colon also is. All right. All right, so this tests your understanding of that. Creating new strings from a string. Programmer often needs to transform two strings into similar formats to perform a comparison. And so, this returns a copy of the string. This doesn't change. Okay, this returns a copy of the string where the first character is capitalized. This returns a copy of the string where all the caseable characters are lowercase, uppercase. This strips the white space off the ends of the word, and it's very valuable because lots of times you read stuff in and it could have a tab, or it could have a return character at the end of it, or some spaces, or and this thing just strips them off so they're tight, so you can compare them. And then this returns the string as a title with the first letters of each word capitalized. And you can cascade these methods like this. So you read something in, and then you strip it, which means you take the spaces off the ends of it, if there are any spaces, and then it makes it lowercase. So here is tests your use of these characters. Someone might, answer questions by entering in lowercase instead of uppercase. It's probably what this. Okay, so anyway, you can see what it does. So the first command is add, and here we add, and then enter past your name, and that's going to be Dusty Baker, and then these the available destinations, and it's going to say, it says Phoenix, and then it must print that out, and then you enter in another command. So what happens? Lowercase. Now this says, okay, yeah, the case. Oh, user inputs. Okay, so this is the menu prompt. Okay, so anyway, so I guess the point with this is it doesn't matter. Does it title a passenger's name? It does. So if I go, it doesn't really show it, does it? I guess it shows that. Okay, so let me make this a lowercase d, a lowercase b, and make this phx like this, phx, and let me make this add, and let me make this print, and let me make this exit. See if this what this does. Does this? See? So it fixed everything because it used title and it used upper to. If I typed them in lowercase, it converted them to upper and so on. So complete the if-then statement to print LOL means laughing out loud if the user contains LOL. Well, anyway, you can do that. This is too easy. Assign decoded tweet. Where are we? We're in no string methods. Okay, good. We only have one more section after this. Oh, yeah. Okay, so I'm supposed to replace this with talk to you later. User tweet dot replace TTYL with talk to you later. Nice. All right, what's next? Splitting and joining. Good. Finally, this is the end, right? Okay, so splitting means you can take a string and split it up into a. Oh, do we know? Have we? Okay, so anyway, you split it up into a list of strings. So yeah, right. You can split a string up into a list of strings, and so you specify the split character. And if you don't specify a split character, then it defaults to a space. So, for example, if you have this string and you split that string based on and the split character is a space, then actually it's any white space, it can be tabs. Then it's going to return this, a list of strings. There's four of them because there's 3 spaces in it. But you don't have to use spaces. You can use something else. You can use tabs specifically if you're doing tab delimited, spreadsheets or something. But anyway, so this is here the split character is a hashtag, or as we used to call it, a pound sign. So that's pretty straightforward. Oh, that's how you would take a URL or a path to a file and split it up into the components. Very simple. Yeah, so here's an example of splitting everything together. Okay, and then joining is joining them back up again. Do we get to join it? Okay, we're going to be joining in a second. Right. So this splits on the /. And there's an empty space here because there's an empty space there. I mean, an empty character, or no character. All right, so this tests your understanding of split, ice cream. Oh, what's the split character? It's a space. So it's just going to be this one. What's the answer? Guess it's going to be this because this is the split character. There's only one of them. It's this. And to the left, there's a whole sentence, and to the right, there's nothing. So on the left, there's the whole sentence, and to the right, there's nothing. So it'd be this one. All right, joining is joining it back up together, joining it back up again, and so you give it the character is the object or the string. The join character is a string, and then you do dot. In the method, the argument to the join method is the list of strings or tokens, as they say, to join up using this join character. Separating them by that. So here, for example, you've got this and this and this, and you want to join them up using the slash operator. You said slash operator join the list, and lo and behold, this comes out. It's got the slashes in between. This is going to join everything together on an empty space, so it's just going to concatenate all of them together. The period, the period is here and here. And so that's why there's a period here and here. So yeah, this is pretty obvious. You can, without this join thing, this join method, you would have to use a for loop to join them together. You concatenate them one at a time like this. Or you may put phrase for, this is when you're joining on nothing, but if you're joining on a character, you would have to put the character along there with it. And then you'd probably have to, there's going to be probably an extra character at the end or an extra character at the beginning. And you'll have to slice that off. All right, let's test that using the joins, split and joins together, huh? I see. So you want to change it from Unix Linux to, oh, what is this? Oh, I don't know what this is. Okay. Oh, yeah, I guess in some languages that means something. Anyway, so this gives you some more examples of when splitting and joining can be used, and so you can look at this. It's all kind of using this more of the same. So let's do one of these. So this is the info. It's this, and we're going to split that based on, oh, let's start it up. say, so we have this, we're going to split it on the space, and then we're going to say that the item is the book, quantity is the 11, and price looks like is that, because this is token 0, 1, 2. These are item tokens. So then what's it going to print? It's going to print book space stock colon space 20. Okay, is that right? So that's going to say price colon space, what's the price? 20. This must be 11. This must be 20. Enter. Okay, so book stock quantity is this. Okay, so I think this is it. All right. Okay, extract area code. Oh, this is a good one. So we're going to split on the hyphens. Oh, this is much easier. So we're just supposed to extract out the area code. Oh, segments. Okay, so we go number of segments equals is it that's joining. Oh, it's phone number split. Oh, split on a hyphen. And so the 0, 1 would be the area code because that's that one. Okay. Yeah, that looks good.